and then we'll get rolling. So thank you so much for joining us tonight as we talk about student-driven investigations. I want to take a second to introduce those of you who haven't joined us before to our platform Zoom. So when I went full screen and shared my screen, you probably went full screen too. So I actually recommend that you exit full screen, and you can do that by going to the top bar on your screen and hitting exit full screen or hitting the escape button. And this is going to allow you to then dock the chat window on the side. We will be using the chat window a lot tonight, so you're going to want to find the chat button that has a little speech bubble as an icon. That should open it up and dock it on the side of your screen. And then where it says to from the drop-down menu, please make sure that you select all panelists and attendees. This will mean that you guys can have conversation with each other as well as myself and Jen as we progress through the night. And let's go ahead and give that a quick test. So in the chat window, let us know where you're from and what your role as an educator is. Children's librarian in Seattle. Awesome. I just went to Seattle for the first time and it was beautiful. Home educator in Northern Georgia. Awesome. Middle school teacher, Virginia. Navy 4-H partnership. Cool. New Hampshire. Based in Georgia, but work for NC State. Cool. Nebraska Parks and Rec. Awesome. Environmental educator from Berks County, Pennsylvania. Cool. A nice range of people today from formal and informal educators. So please do feel free to share your experiences with citizen science and inquiry and student-driven investigations in the chat window as we go on. I'm sure there's a lot that we can learn from each other. So I'm coming to you live tonight from the Cornell Lab of Ornithology, which is not at all green this time of year. In fact, it's white, white, white. And our mission here at the lab is to interpret and conserve the Earth's biological diversity through research, education, and citizen science focused on birds. Specifically, I'm with the K-12 education team, where our mission is to create innovative resources and trainings that build science skills while inspiring young people to connect to local habitats, explore biodiversity, and engage in citizen science projects. My name is Kelly Schaefer, and I'm the outreach coordinator with the program. And joining me in the chat window tonight is Jennifer Fee, the manager of our K-12 programs here. So Jen will be able to help answer some questions, maybe share some links, and flag me down for things that we should discuss. So let's go ahead and dive into our webinar tonight, where we're going to be discussing student-driven investigations and how they really dovetail super well with our next generation science standards, our Common Core standards. We'll talk about citizen science projects that you can get involved in, both in ornithology, and we'll talk about how to find ones outside of ornithology. We're also going to take a look at some case studies of educators who have done inquiry projects in their classrooms and what those projects have looked like. And we'll also talk a little bit about how to develop questions into studies. So hopefully there will be some good information in here for everyone tonight. And again, please feel free to share thoughts and questions in the chat window as we progress. So I wanted to take a moment to share these 3 pillars with you, which are kind of what we base our resources on. So all of our resources touch on some or all of these pillars of nature connection, citizen science, and inquiry. And as we discuss student-driven investigations, we're really going to be focusing on citizen science and inquiry. But as these projects take place outside and get students involved in close observations, they're also building that nature connection as well. So before we get too far along, let's make sure that we have a shared definition of citizen science. So in the chat window, why don't you take a moment to put in some key words or thoughts or examples or definitions of what citizen science is or what you think of when you hear citizen science. Individuals observing and recording. Awesome, I like that, Julie. Everyone's investment in science, I like that. Everyday people contributing to science data gathering. Groups studying together. So I like that you guys are hitting a lot of really cool points. Regular folks participating in science, sharing that data, and working together. Lisa's saying that she thinks of Bluebird trail monitoring and feeder watch. Yeah, those are both pretty classic citizen science projects. Rachel's saying that there's a skill building component in citizen science, and I definitely agree with that, especially when we use it in our classrooms and in our educational settings with our youth. Helping collect data for scientists. Yeah, so we really do, you guys are hitting on all these awesome points about citizen science. We really do view citizen science as a partnership between everyday folks who aren't professional scientists and professional scientists. So regular folks like you and me who might not be scientists for our professions, go out, collect data, make observations on the natural world, send those observations to databases that scientists can then use to answer real world questions. And I think that real world question component is such an important component of what makes citizen science a powerful educational tool. So there are a number of different projects out there. So if birds aren't your thing, which I don't know why they wouldn't be, but then I am very biased. If birds aren't your thing, there is a citizen science project out there for you. You want to look at clouds, there's a citizen science project for that. Bugs, flowers, go ahead, check out Project Budburst and get into phenology. Go watch some worms. There's all sorts of really amazing projects out there, so you have the opportunity to find the project that's right for you, your educational setting, or the interest of your students. So you can tailor the projects that you involve in to be the most impactful for your students. And here at the lab, we have 5 major citizen science projects. So we have Project Nest Watch, the Great Backyard Bird Count, Celebrate Urban Birds, eBird, and Project Feeder Watch. And one of the things I want to draw to your attention is that some citizen science projects do have a limited range of time that they run, so like a specific time of year. So for example, the Great Backyard Bird Count runs for 4 days every February. Nest Watch, of course, is in the nesting season, so that's going to be spring and summer. Feeder Watch does a snapshot of birds from November to April, whereas Celebrate Urban Birds and eBird can be done year-round. So that's something that you want to be aware of as you're planning for using citizen science projects in your classroom, is to match it to the time of year that your programming is taking place. And there's lots of really great resources out there to help you get started. We'll touch base on those for a minute. But why use citizen science with your students? As we've talked about, it's real world. You're helping scientists collect data and answer questions about the world. It also provides you with a really cool opportunity to incorporate your local habitat into your studies. So you have the opportunity to go outside and make observations of the plants and the animals that share the world around you, which I really think helps build those nature connections that I mentioned earlier. Plus, it helps build STEM content and science process skills because you're going out and you're collecting data. You're building all these important skills. So let's just focus in on that for a second. So a lot of educators are concerned with meeting the next generation science standards. And what's great about these science standards is while they incorporate content, they also put a lot of focus on some critical skills that students need to be scientific thinkers. So it pays appropriate attention to science as a mode of thinking and a mode of examining the world. So participating in citizen science means that you're following basic scientific protocols, that you're collecting data, that you're submitting that data to scientific databases. So that's going to meet a lot of these cross-cutting concepts, a lot of these scientific practices. And then when you take that further and then start incorporating inquiry, which we'll talk about in a moment, you're asking and answering your own questions, you're planning out investigations. So that kind of fills out some of these science process skills. What I like about incorporating citizen science and inquiry is that citizen science gives kind of a more structured view of participating in science, so following these protocols and seeing how a scientific project can be set up and what data collection might look like before diving into it on your own. And of course, the content that you're going to meet is going to be dependent on what citizen science project you choose. So if you have specific content standards that you are trying to meet, you might be able to find a citizen science project that is going to help you meet those. All right, so we dove into those STEM skills. But as I've mentioned before, that real world aspect, that's so motivating for kids. They know that the data that they're collecting helps, that it matters. So it sort of answers that essential question for kids, why are we doing this? And it helps to create kind of a sense of community, both in the place where you live, but also a connection to the scientific community. And it helps children sort of change the conception of who can be a scientist by making them feel more connected to the scientific community themselves, and maybe ultimately helping to improve their own science identity, their own ability to view themselves or people like them as scientists. Plus, it sparks their curiosity. It's just an awesome way to engage students in the scientific process. And hey, it's fun. Kids get to go outside, collect data, experience a different side of science than what they might be more used to. So some resources for getting you started on citizen science are, I recommend the Citizen Science Association, citizenscience.org, and then scistarter.org, which is an awesome web page that's going to help you filter for different projects. You can look for projects by topic, by the age group of the kids that you'll be working with, or by your region if you want to find a local project. And I'm going to ask Jen to share the link to SciStarter in the chat window with you all. So I definitely recommend checking that out. All right, so we've got the citizen science piece of the puzzle. Let's take a moment to talk about inquiry. So what do you think about? What are some keywords or definitions that pop into your head when you hear the word inquiry? Keep asking those questions, absolutely. Trying to answer a question. So yeah, if we were thinking about the most basic definition of an inquiry would probably be to ask a question, right? I like Allison's point, asking questions from what you observe. Wonder, absolutely, yeah. Exploring, discovering. Awesome when you can make it questions that the students generate, very true. Students creating their own questions. curiosity about all things in the world. Awesome. Collecting data and learning how to present it. Asking questions, answering questions. I love it. Yes, absolutely. These are all components of inquiry. And there are a ton of different definitions for inquiry out there. Sometimes it can feel like a bit of a buzzword because there are so many different ways of approaching inquiry. If you're anything like me, when you were in school, you probably learned the scientific method, the classic linear progression of asking a question to doing research to connecting or constructing a hypothesis. And I think in reality, it's a much less linear process. It's a lot more iterative. It's more cyclical, so it kind of feeds off itself. The more you learn, the more questions you might have, or the more you might change your experiment if you're doing one to fit what you've learned. So inquiry has kind of, for me, connotations of a cyclical process where everything that you learn feeds back into what you're doing. And so for what that means for us as educators is if we let go of the reins and we're letting students ask their own questions to study in class, that means that we have to let go of the reins a little bit, which can be just a tiny bit scary. So we gotta keep calm and pretend that we planned for it. But what's really wonderful about inquiry in the classroom is when we let students ask and answer their own questions, it's an incredibly authentic learning experience. It provides them with the opportunity to dive deeply into a subject and practice some of those really important critical thinking skills and science practices that we see in the NGSS standards. So think about inquiry including things like project-based learning, these deep dives into particular subjects, and using all of these different skills that can be integrating a ton of different subjects to answer a particular question. And as I've been saying, inquiry is just inherent in those science practices, because when you are doing an inquiry project, you are hitting all of these different things, asking questions, developing a study, planning and carrying out an investigation, analyzing data. So there's opportunities to meet so many of these science practices in a really authentic way. So this is kind of what I think of when I think of the inquiry process now. I think about investigations, and I think about something that's really iterative, as I said. So I think this image illustrates that really well. How when you are out there making observations, questions naturally arise, and you might design an experiment but make some more observations that mean you got to go back and collect more data and maybe change the way that you are approaching answering your question. And then when you answer your question, usually more questions arise. So it's this beautiful process that just engenders curiosity. I just wanted to throw this quote in there from one of our teachers, that taking students outside and letting them do bird observations was a really great way to motivate them to ask questions in science, because those questions, if you've ever taken kids outdoors for learning, you know those questions naturally arise. And so I wanted to draw your attention to investigating evidence, which is a curriculum that's available to you as a free download thanks to sponsorship. And I'll talk a little bit more about that in a minute. But this curriculum does a really great job of scaffolding this entire process. So using citizen science as kind of a springboard to spark inquiry projects, and then how you would scaffold those inquiry projects and how to support them as they're learning how to participate in science in this authentic way. So I'm going to have Jen share a link in the chat window to that curricula for you. And I just wanted to touch base again on lesson 1, because this is kind of just such a key part of the science process, is that process of observing and wondering and learning that scientific investigations and scientific discoveries really start with just observing and wondering about the world around you and how it works. So giving students an opportunity to explore their own environment and ask questions. So I want to take just a moment to, in the chat window, share some activities maybe that you've used before to help students build observation skills and spark that curiosity. And while you're thinking and typing, I want to share one of my favorite activities to do with students that I think helps build some of those observation skills and get students to think about their environment in a way that they might not have done before. So this activity is called a sound map. And it's super simple. You go outside with a piece of paper, you draw an X in the center to mark where you're standing, and then using words or pictures or whatever moves your students, you draw a map of all of the sounds that you hear around you. And so you might end up drawing the sounds of winds in the tree, or you might notice the sound of the air system for the school that you've never really noticed that you're hearing before, or the road, or birds singing. So what I love about this activity is that it opens up a particular sense, it inspires observations, and it might get people to see something or hear something about their world that they haven't noticed before. One of my favorite instances of using an activity like this was, I was in the North Woods of Wisconsin and it was snowing out, and one student reported that they could hear the snowflakes hitting their jacket, and another student who had their hood up reported that they could hear their own heartbeats inside the confines of their hood. And so it was just a really cool way, and those were high school students, for them to engage with that sound. And you can, tailor this activity to different age groups based on how long you give them and how they record their observations. So some of the things that have been shared in the chat window, Larry loves taking students outside. They have an observation deck, some cams, and students take pictures of prints in the snow and identify them. That's awesome. That's a really cool activity. A lot of people don't think about looking at tracks, and they're so cool. Julie's saying she's done the sound map activity. Awesome. That's great to hear. Nicole's saying they do field work days at local parks and take a nature journal along to draw what we see. That's so cool. Project Feeder Watch Station. Tebo's saying that they didn't have any birds outside last week, so they put out laminated pictures in the trees for an ID game. That's great. I love it. Sue's talking about a nature soak. Oh, I love the name of that. Sometimes we take kids outside for a nature soak so we can listen and take in all the nature has to offer. Awesome. Very cool. Journaling in a schoolyard. Yeah, I think nature journaling can be a really powerful way of doing it too. I love that a lot of you guys are doing that. Providing that opportunity for students to write down what they're seeing can make a really nice connection into recording scientific data. And as we know, nature journals can provide scientific data. Thinking about Otto Leopold here and his phenology observations. Very cool. Those are all great ideas. The next time I'm feeling stressed, I think I'm gonna go take a nature soak. All right, thank you so much, everyone. So let's talk about what happens when you are outside. When you are outside with kids, you see all sorts of really cool things, strange phenomena that you might not anticipate seeing, things that inspire questions, really cool behaviors. And so it's important to think about how you frame your reaction to those experiences and how you help your students start thinking about the things that they observe. So let's focus in on our pigeon here for a second. So this image here, there's a lot of different ways you could approach this with if you observed this with your students. So you might say, look at that pigeon drinking water. But what that does is you basically told the kids what they're seeing as a fact, and that kind of closes discussion around it. Whereas you could use a more open sort of question that is going to encourage students to make observations and make some conjectures about what they're seeing. So a more open question might be, what species is that? But that question only has one right answer. And if the students don't know that answer, they might not feel welcome to participate. So you could open it up just that next step further. What clues could we use to identify this species? Well, there more people can start to participate. It's a more open question. And then you can start moving that along even more to, what is it doing? Why do you think it's doing it? And connect it to concepts of survival. So it's drinking water. Why does it need to drink water? How do birds that don't have access to fountains find their water? Do all birds drink from fountains? Will putting out a bird bath attract birds? So you can see how if you open up the question, or you open up your response to the observation, it can create more room for more questions. That kids are just really, really good at coming up with all of these connected questions. So what's really great is from those questions, for example, let's look at our bottom one, will putting out a bird bath attract birds? You could then decide, hey, I wonder if that really will happen. So you could design an observational study or an experimental study to go ahead and try to sort that out and answer your question. And whether you're doing an observational or experimental study, you're going to be collecting data, answering questions, sharing your findings, using reference materials. So the way you design your study might be different, but a lot of the core pieces are going to be the same. And again, this is all covered in the investigating evidence curriculum that we mentioned. So I wanted to take a second to highlight a question that came out of an old inquiry course that we had here at the lab. Somebody was sharing an observation about cardinals at their feeders and noticed that their cardinals were really territorial. So most of you have probably seen or heard of cardinals or other birds attacking their reflection in the windows. And so my question for you is, if you were curious about why cardinals were aggressive toward their mirrors, or you're curious about how cardinals are aggressive towards mirrors, what kind of question could you use or could you create to inspire an investigation? So how could you frame that curiosity into an investigation? So I'm noticing that a couple folks in the chat window are still using all panelists. Just want to take a second to remind you to switch to sending your messages to all panelists and attendees. And you'll find that option in the drop-down menu next to the to button. So you can start by looking at the number of cardinals in your area. Nicole's suggesting looking at male and female cardinals and seeing if one is more territorial than the other. That would be a cool study. Any other thoughts on how you might investigate territorial reactions in cardinals? And while you're thinking, I could share a little bit more about this particular question. Oh, cool. Sue's wondering if a type of feeder or a type of seed might make cardinals more territorial. So maybe there's a food that they prefer and that they will then spend more energy defending. Cool. Lisa's wondering about cardinals and whether they're more or less territorial when food is abundant or scarce. That would be cool. Ah, Michael's asking about territoriality at different times of the year. Very cool. Those would all be some interesting studies. Some of them might be more challenging to set up than others. Very cool. I love those ideas. In this particular example, Tommy was interested about finding out whether male cardinals would respond to a 3D model of another cardinal. So would they be aggressive towards a 3D model, and how could they set that experiment up? And so if you're curious about something like that, that's kind of a big, broad question. So you have to figure out what your experimental setup is going to be. So you need to refine that question into something more specific. So you got to figure out how that 3D model is going to be treated, and whether you're just curious about the 3D model or if there might be another component that you're curious about. So in this example, Jen suggested also checking out songs and using a combination of a decoy, so a 3D model of a cardinal, a recorded song, or a decoy and a recorded song, and then measuring territoriality regarding that. So then you also have to decide what is a display of territoriality. So there are all these sorts of different questions that you will have to then start asking yourself as you're refining your question and beginning to set up an experiment. And so I wanted to draw your attention really quick to a really wonderful tool that you will find in investigating evidence called the I Wonder board. And so this I Wonder board is really good at capturing those questions. So you're curious about territoriality and cardinals. Awesome. Put it on the I Wonder board. And this is a great way to capture all those questions that you don't know the answer to in the moment. It's also a great way to store your students' curiosity for when you get to the question refining stage. So then you can go to the I Wonder board, look at some different curiosities and observations that are on there, and then find one that you can refine and turn into experiment. There's a lot of help for this step of the process within investigating evidence. It goes through the different kinds of questions that you can ask, the different types of studies that you can do, and has some great slideshows about how to set up your experiment so that it is fair. So let's take a second to talk about setting up fair experiments. So let's talk about an experimental study. So that's going to be a study in which your students are going to be manipulating a variable and then looking to see what happens. And so there are several examples of bird experiments that we see quite a lot, and one of them is this. Asking the question of what color bird feeder do your local birds prefer? So that can be a really fun one to test. But if we want to do this experiment, we got to make sure that we are setting up our variables well. So let's take a second to review those. Our independent variable is going to be the one that we are changing for the experiments. The independent variable is being changed. And then the dependent variable is what we're measuring to see if that change had an effect. And then there are constants or controls. So all of these things that we need to keep the same, and we need to keep them the same so that we know that the variable that we're changing is causing the effect that we observe. So that's just how you help narrow things down. So for an example, if we wanted to test that red, blue, and green feeders, this is how it would shake out in our variables. And I definitely recommend doing charts like these with students. I think it's a really helpful way to visualize and understand the different variables. So our independent variable, or the thing that we're changing, is going to be the feeder color. But the things that we want to keep the same, our constants, are going to be the type of feeder. We don't want to have like a tube feeder and a suet feeder and then just some seed on the ground. We want to make sure that the feeder type is the same. We want to make sure that the kind of seed is the same. And we want the location of the feeders to be the same as well, so that none of those factors are affecting what we observe. And then in this case, we could do the amount of seeds. So what's cool about this experimental setup is that you don't even have to be able to identify birds. You don't have to be sitting there watching your feeders constantly and counting birds. You can just look at the amount of seed eaten to try and determine which feeder is preferred by your local birds. And that's exactly what this group of students did, the fledgling ornithologists. They did an experiment with yellow, blue, and red feeders, and they hung them out, as you can see on the shepherd crook. So they were all at the same height, all in the same location, all the same type of feeder. And then they very carefully measured the amount of seed that went into the feeders and the amount of seed that came out of the feeders to determine the preference. And what's funny is when students do this experiment, there usually is a feeder that is preferred, but the color is not consistent across different regions. So in this experiment, I can't really recall, but I think it might have been the blue feeder that was preferred. But we've had studies where it's a red feeder that's been preferred too. So I'm not sure what it is, or if there are certain areas where birds really do prefer red. Goodness, sorry for that picture. I don't know where that came from. Huh, give me 1 second here. We're gonna get rid of that. All right, there we go. So I wanted to share this example with you, which was published in a recent Bird Sleuth Investigator magazine, which is our student publication where we publish student scientific investigations. And this was an experiment done by the Early Bird Club, which is a K through 4th grade club. And they were curious about homemade versus store-bought suet and which the birds would prefer. And you can see here the homemade suet on the left and the store-bought on the right. So if you were setting up this experiment, how would you go about measuring the preference of these birds? So we know that our independent variable is the type of suet. How would you measure, what would you make your dependent variable? What would you be measuring? Hunter and Julie and Lisa all suggest using mass. And Allison, yeah, you guys are all on top of it. And the Early Bird Club agreed with you. That's exactly what they did. So they used the mass of their suet cakes. And so their mold for the suet of the homemade variety was a little bit larger than the suet, but it was thinner, the store-bought suet, so it's thinner. So the grams ended up being pretty different between them. But what they found was that every time they put out a homemade cake, it was gone by the next time they met, while they only ever went through one store-bought cake. And there was some of it eaten each time, but nowhere near the amount of their homemade cakes. So they determined that they had found a really good recipe that their local birds preferred in their homemade suet cake. They did, of course, do some really good thinking about whether there might be other confounding factors. So they wondered about whether their suet cake maybe had a little less integrity, so maybe it fell apart and other animals ate bits off the ground. If the size mattered, because maybe bigger birds liked the bigger feeder, that sort of thing. But that's what we love about scientific investigations like these is you investigate one aspect of it and you dive into that and you realize that there are more questions to investigate. So another type of study that you could do would be an observational study where kids are making observations and collecting data, but they aren't really trying to change variables. So a suit example for this would just be questioning what kind of birds come to a suet feeder. So this particular group of students were curious about whether suet would attract insectivorous species. So they observed the birds that were visiting their suet and determined what sort of birds they were. Were they seed eaters? Were they insectivores? Another great example of an observational study is the effect of snow depth on bird counts. And this was done by, I believe it was a K1 class. And what I love about this experiment is that they did not need to identify birds to do it. They were looking at the number of birds and the snow depth. So they were building skills that were age appropriate. So they're measuring skills and they're counting skills. And they were able to do a scientific investigation. So that's really, really fun and really cool. And then, of course, there are other kinds of studies that you can do, like data exploration studies. So I'm going to take a minute to share with you some cool features on eBird, which is a citizen science project from the lab that is the largest largest biodiversity related citizen science project in the world. All right, so you should be seeing my screen right now. This is eBird's homepage. And I did want to take just a second to scroll down and look at the stats here, because I think it's really impressive. So we can see that there have been more than 40 million checklists submitted to eBird, that there's more than 500,000 eBird users out there, and that 10,508 species. And I want to say that there's something like 10,720-ish species of birds in the world. So eBirds has recorded more than 98% of all the bird species in the world. And that is because regular citizens like you and me are out there participating in these projects. So it is really, truly people-powered science. And what's really cool about these projects is the data that those 40 million folks are helping to collect comes into the eBird database, and you can check it out. So your students have access to that data. So I'm going to go ahead to the Explore tab here on the eBird website. And I'm going to scroll down to these different menu options here. So what's really cool about eBird is if you're an Uber birder or just a bird nerd like me and you want to go see a specific species, you can look that up and figure out where they are near you to go see them. But how I use eBird with students is usually I come down here to this bar chart option. So I'm going to go ahead and select that. And this allows us to look at birds in different areas and see the data that's been collected on those. So I'm going to go ahead and I'll select New York since we are live from Tompkins County, New York. I'm just going to select the entire region of New York. I could focus in on just our county, or I could even go to a particular hotspot if I knew there was one nearby. And then I'm going to go down here to continue. And then it's going to pull up this graph of all these different birds, which let's check out the Canada goose here. We see these green bars in here, and the taller the green bar is, the more likely you are to see this bird at that time of year. So we can see that the Canada goose is here year-round, which I'm sure surprises pretty much no one. So Canada geese are our constant friends here in New York. They're always around. We can see some fluctuation in the frequency they're observed. And then we can come down here and scroll through some of these and check out other species. We see that there's quite a difference in the frequency that these birds are seen. This is a ring-necked duck. We see them a fair amount in the winter and spring, but almost not at all, very infrequently during the summer. So we can make some inferences from this data as well. Let's scroll down a little bit here. Let's check out the ruby-throated hummingbird. So we can see that we have bars in April through October and some in November, but none in the depth of winter. So what inference can we make about this bird based on this graph, based on this chart? Migration, absolutely. They like it warm, for sure. They're migratory birds. They hang out with us in the summer, and then they're gone. And that makes sense with what we know about ruby-throated hummingbirds. Hummingbirds drink nectar. There are not flowers in Ithaca, New York, or anywhere in New York in the winter. So they don't have food, so they better find somewhere else to be. So they're migratory birds. So what's really cool about these bar charts is we can make inferences about birds and their behaviors. Now, the next thing I want to show you are line graphs, and you get to those line graphs by clicking on this icon here. And then you can see the data in a different form. So we can see that same data in a different form. And this really, for me, brings home that migratory aspect. And what's cool about these charts is that you can add additional species. So I'm going to go up to here to bird observations, and I'm going to change the species. And what kind of question could we ask with some of this data? Maybe we're curious about different kinds of birds that eat different things and whether they're around during the winter or not. So let's put in a raptor. Let's put in a bald eagle, something that eats let's put in something that eats insects. Let's do wood thrush. Let's put in something that eats a lot of fish. We'll do a belted kingfisher. And then let's do something that eats seed. It's like a northern cardinal. All right. We can see our bar graphs here, and then we can scroll down and see the line graphs. Wow, who's the purple? Northern cardinal. So if we're looking over here on the y-axis, this is the frequency or the percentage of checklists that these birds are reported on. So if you were to go out in New York in, let's see, early May, you had a 55% chance of recording a cardinal on your checklist. And we can see that cardinals are by far the most common bird of the ones that we selected. And I'm seeing in the wood thrush, the yellow line, and the ruby-throated hummingbird, the blue line, that same trend of being gone for part of the year and being present for part of the year. So we can say that they're both migratory, and our wood thrush was our insectivorous species. So our insectivore and our nectivore and our hummingbird are both migratory. Looks like the cardinal hangs out year-round. Makes sense. Seeds are available year-round. The bald eagle, though in the pink line here, though it's much less frequently reported, is reported year-round. And we see that, I'm a little surprised at the kingfisher. They're still around. I guess as long as there's open water, they can find food, although they're much, much less frequently reported in these winter months. So you can start to see how you could investigate some fun questions using the data that's been submitted to the eBird database. So if you're curious about how different birds with different diets react in your area, you could have a student do a eBird data study as well. So there's all sorts of really cool options available to you out there. And I encourage you to take some time and explore the eBird database because it is a lot of fun. All right, so I'm curious how you think student-driven investigations might work in your setting, and what sort of questions could you see your students asking? And they don't have to be bird related. If you maybe have a school garden or something like that, please take that into consideration as well. Alice is saying that her students would be really likely to ask, where do the birds go if we don't see them? It's a good question. Might be a tough one to investigate, but you could find a way though. Wonder if there's a way to do like a trail cam study or something. Larry's saying his students might ask, what kind of plants should we put in our school garden? Where should you put your trail cams? Yeah, so the question about plants in your school garden is an interesting one, because it could be a reference question to some degree. Like you could look up native plants to your area, but you could also investigate what birds you see around and then find the plants that they prefer. Where can you look for birds? Cool. Yeah, eBird could be a good resource to answer that kind of question too. What kind of feeder attracts the most birds? That'd be a fun one. Does temperature affect the number of birds at a feeder? That's a great question. Oh, you have some construction at your school, and how does that affect them? That's cool. That would be a neat to do, like a before and after study, or a during and after study. Lisa's saying that her IB juniors develop research questions using historical data from the Christmas bird count. They use statistics to investigate and then make poster presentations to the juniors coming up the next year. That's super cool, Lisa. I'm wondering if you have seen the study that was published in Science in October that used Christmas bird count data, the 3 billion bird study, that showed that birds in North America had declined in just the last 50 years by 2.9 billion birds. So citizen science data, I mean, I don't want to say real scientists because your students are real scientists, but professional scientists are using that same data to answer important conservation questions. What birds live on your school grounds? What food do they prefer? What animals are active or near school grounds in winter? Very cool. So you could go outside and make observations on your local birds and then do some research on the type of food they prefer and then set up an experiment to see how they react to those foods. That would be super fun. Awesome. These are all really cool questions. It's nice to hear some about your different settings and how they might be used. So I wanted to draw your attention in case you are interested in more professional development around this subject. We do have an online course that you can participate in called Inspiring Investigations Through Citizen Science. That's on our Bird Academy platform. And you can get 2 CEUs through completing this course. Or if you are in need of graduate credit, you can also take it through graduate credit through our friends at Drake University. And Jen's going to share a link to the course with you in the chat window in a moment here. And then I did want to just take a moment to thank our sponsors from 3D Pet Products, Wild Delight, and Better Bird for making the investigating evidence curriculum that we've talked about tonight available as a free download. And then open it up to you for any questions. So if you have any questions about what we talked about today or implementing in your classroom, please feel free to put those in the chat window. While you're doing that, I also want to draw your attention to the NSTA chat with Ancella that's about to start at 9 o'clock tonight using the hashtag NSTA chat, and it's talking all about science leadership. So we'll be taking part in that Twitter chat, NSTA chat, and we hope that maybe some of you will come join us and respond to questions with the hashtag NSTA chat. We'll be on there from our Twitter handle at K12_lab. And if you come up with any questions after tonight, you can always get in touch with us through Twitter and Facebook, or reach out to us via email at k12lab@cornell.edu. If you are interested in receiving a completion letter for one contact hour for this webinar, you can go ahead and send us an email at k12lab@cornell.edu, and we'll get that out to you probably by Friday afternoon. Hunter, yes, this webinar was recorded, and I'll put up either this recording or the recording of the Tuesday webinar on our YouTube channel. Probably tomorrow it'll be up, and I'll send out an email to everybody who registered. Nicole, that's a great question. So Nicole's asking for the I Wonder board, since I teach multiple grades, should I make multiple boards or one combined board? I would recommend one board per class, I think. It's nice for students to be able to track their own questions and kind of work together as a unit, because sometimes you'll notice that they start building off of each other. And so each different board might have its own flavor. Each different class might have its own flavor of question. I'm sure you could do it with a single board, but I think my gut instinct was to say multiple boards. All right, well, it is just about 9 o'clock. I'm gonna hang out for a couple more minutes. I'm gonna go ahead and mute myself if there aren't more questions. But I do wanna say thank you so much for joining us tonight. Oh, here's a question. How far after do I publish the investigations done by students? So the Bird Sleuth Investigator magazine, the year of the magazine reflects the year that the student work was done in. So it's work from 2019 was published this fall. Yeah, thank you all so much for joining. Debo, you're asking how you get Bird Sleuth. So Bird Sleuth was the name of this program up until about a year ago when we switched to K-12 education. So there's not one way to Bird Sleuth. We have a suite of curricula and lessons and professional development opportunities. My best advice for you to get more involved would be either email us with specific questions, but definitely check out our website, which you can see on the screen right now, www.birds.cornell.edu/K12. Wilhelmina is asking, what's a good birder book for kids to identify birds? Oh, I'm sorry, Deb. I totally misunderstood your question. Bird Sleuth Investigator. Here, I will stick in. Oh, Jen put a link up and she's going to stick that in the chat window again. I'm sorry. I totally misunderstood your question. Sorry, Wilhelmina's asking about a good birder book for kids to identify birds. Oh, that's a tough one. There are all sorts of different field guides out there. A lot of what's right for you is going to depend on preference and the age of the kids that you're working with. I prefer drawings in field guides to photos. Some people are totally the opposite. And if you are working with young students, you might want to get a smaller bird book that is specific to your region. I definitely recommend Merlin, which is the free bird identification app from the lab. It's really great because it narrows down the birds to the ones that you might see in your area at that time of year. So it makes bird ID simpler, and it helps kids be successful from the start. So if you have access to technology, I recommend the free Merlin Bird ID app. Oh, cool. So Hunter's asking about implementing eBird and nature in an art program. That's super cool. Yes, actually we incorporate art into our bird ID. And so I'm sure there's a spin on that you could do to bring the art forward. So we do something called a focus bird. And so we'll assign each student a bird that they might see locally, and then get to know that bird. They research the bird, they draw pictures of the bird, and they become the bird ID expert on that particular bird. So then when you go out on a bird walk, you have 10, 15, whatever, 25, whatever your class size is, experts on one bird. And so I'm sure that you could incorporate that into an art program and maybe make going on the bird walk to identify the birds and collect an eBird list is kind of like the celebration and culmination of getting to know that bird in an artistic way. Nicole's suggesting the laminated trifold pamphlets for bird ID. And they have state and regional ones. Yeah, those can be really great for kids too. If you are going to be seeing what you think are pretty common birds, then that's going to cover a lot of it, or at least be a really great place to start. Wonderful. Thank you all so much for these great ideas. I'll hang out for just another minute, but I am going to stop my screen share here, so it's going to get a little boring to look at. But as I was saying, if you come up with questions later, you can always reach us through email. We're always happy to chat.